ways of solving a matrix equation of the form AX equals B, where A is your coefficient matrix, it's your 2 by 2 square matrix. X is your column matrix, which contains the unknowns X and Y, and B is your column matrix, which contains the constants on the right-hand side of the equation. If you were to write the equations in the form, for example, AX plus BY equals C. The first thing we're going to do here is I'm going to assign matrix A is going to be our square 2 by 2 matrix. So what I'm going to do is I'm going to say A. I'm going to press A. Now, when in mathematical notation, A, X, and B are uppercase. There's no point having uppercase in TI-Nspire, because if you did show an uppercase letter and press enter, it becomes lowercase anyway. So just make sure that you know the distinction between capital letters or uppercase when you're writing or denoting matrices on paper, and then in Nspire you'll be assigning matrices to lowercase letters. So we have matrix A. Now the assign command, it's on the keypad, and it's linked to the symbols template button, and it's colon equals. It's a colon equals is the assign command, and you access it by pressing Control and then the symbols template. So it's colon equals. It's not equals. It's colon equals. That's very important to recognize. And so we're going to denote this one to be, if we go into our catalog, 2 by 2 matrix. Okay, so let's denote matrix A to have elements 2, 4, 1, and 5, and then press enter. We want B, control symbols template, so we want to assign matrix B to be a column matrix. So if we press the catalog button, there's our 2 by 1 matrix template. So if we press enter, and what we'll do is we'll make that element 6 and that element 9, and then press enter. So in effect, the system of equations that we have here is 2x plus 4y equals 6, and x plus 5y equals 9. We've got our matrix A and our matrix B, and so our first method, the method that I want to show you to start off with, is the inverse matrix method. Basically what we're saying here is that if we have a matrix equation, AX equals B, we can therefore say that X is equal to the inverse of A times B, right? It's pre-multiplication. So it's the inverse of A times matrix B. So just to be really careful and make sure that our answer, we see an X and we see a Y, what I'm going to do is I'm going to introduce another column matrix. So if I press the catalog button, there's our column matrix, and I'm going to say X, and I'm going to put Y in there, and I'm going to say that that's going to equal the inverse of A times column matrix B. So all we need to do now is, with A and B assigned, we just need to deal with A and B rather than typing in or mucking around with the 2 by 2 coefficient matrix and the column matrix. So all we need to say now is we need to say, well, okay, this is going to equal A, and notice that the A is bold and non-italicized, and you get that representation when you've got something stored or assigned to A. So that's a good sign. Now, the other thing with matrices is that we can also raise them to particular powers. And as we know, the way that we denote the inverse matrix is it's A to the power of -1. So if we press the hat key there, or the exponentiation key, then -1. And now what we want to do is we want to multiply that by matrix B. All right, so we're dealing with the letters. So once these are assigned, it's quite simple and to use. We end up here now with xy equals the inverse of A times B. And if we press enter, what we should get is we should get a solution. Now, I wouldn't really advocate writing the solution like that in the exam. X equals -1 and y equals 2. But the reason why I've set it up like this is it just gives you an extra bit of information so that you don't muck up x and y. You know, x equals -1 and y equals 2. I mean, you can also, by all means, just have the inverse of A times B and just end up with a column matrix there, -1, 2, and recognize that x equals -1 and y equals 2.